In the previous lesson, you learned about alpha particles, the biggest type of radioactive particle. In this lesson, we're going to learn about the next type of radioactive particle, which happens to be the smallest type, the beta particle. Just like alpha particles, beta particles are all around us in nature and used for many man-made applications and technology as well. We're going to learn what the properties of beta particles are, what its range is in matter, how you can shield against beta particles, and what makes beta particles so dangerous. Let's get started learning about beta radiation. Now, beta particles, just like alpha particles, are made up of the smallest pieces that make up atoms, except remember, an alpha particle was 2 protons and 2 neutrons, a really big particle. Beta particles, just the opposite, are tiny. A beta particle is just a single electron moving at a very, very, very fast speed. Now, there are electrons in the air all around us, free electrons that are able to combine with atoms and make ions and things. What makes a beta particle so special? What makes it radioactive? And like I mentioned, it's the speed of a beta particle that makes it radioactive. It has a tremendous amount of energy because it moves very, very quickly. Additionally, beta particles, because they're electrons, have a 1- charge. And they also have the tiny mass that comes along with being an electron. Because their charge is small and their mass is small, beta particles are able to travel a lot further through air and through matter than alpha particles were able to. The range of a beta particle is somewhere between 5 and 10 feet in air, and they're also able to penetrate human tissues to a depth of a couple millimeters. Now, that's deep enough to reach the living tissue underneath the skin, which alpha radiation couldn't do. It was trapped in the dead outer layer of skin. So beta radiation can be dangerous even from outside your body. However, it's extremely easy to shield against beta radiation because it's just not that dangerous. It's not able to penetrate that well. You can shield against beta radiation by using thick cardboard, by using aluminum, or by using plastic. Scientists advise against using really thick, dense metals to shield against beta radiation because when beta radiation approaches dense metals, sometimes it can release X-ray radiation, which is also ionizing and which is also dangerous. So cardboard, aluminum, and plastic do just fine to stop beta radiation in its tracks. Is beta radiation an external or an internal hazard? The answer to that is, it's both. It does different things internally and externally. Internally, if you inhale, absorb through your skin, or ingest a beta source material, those beta particles being released inside your body can harm your deep tissues like bone marrow or your organs. From the outside, beta radiation can't get that deep into your body. So from the outside, it's harmful to your skin, and it can even harm your eyes, where you have a lot of very fast reproducing cells whose DNA is susceptible to being damaged by beta radiation. So beta radiation can be harmful both from the inside and from the outside, and it does different things on the inside than it does on the outside. Let's take a look at how beta radiation is ionizing radiation, and it might not be like you think. You may think that because beta radiation is an electron, it would just join to the outside of an atom to ionize it by adding an electron, but that's not how it works. Once again, here are our carbon atoms, like the carbon atoms that are in your DNA. We're going to see what high energy beta radiation would do to the carbon atoms in your body. First of all, momentarily, the beta radiation would join with an atom of carbon to make it an ion, but for just a little bit. This beta particle still, once it joins with the carbon, has a ton of energy. Too much energy to remain stable in that neutral atom. So what's going to end up happening is it's going to impart some of its energy to another electron, and then both electrons will have enough energy to completely leave the atom together. As the size of the arrows show, their energy is much less than it was at the beginning with the original beta particle. These would be just free, non-radioactive electrons in the air that would be able to join with atoms and make ions or neutralize ions or whatever. However, the damage has already been done. One of the electrons has been removed from the original carbon atom in the molecule, which means that one of the bonds is going to break, and that molecule of DNA is now changed into something else. Again, when that happens, the cell that contains this DNA may die. The body may repair this DNA breakage, or this difference in the DNA may lead to a mutation that gets copied again and again by cells in the future, which could lead to cancer. Hopefully now you understand the basics of beta radiation. Beta radiation is made up of energetic electrons, very tiny mass, a 1- charge, can easily be shielded by thin layers of aluminum or thick cardboard, and can be harmful both inside and outside of the human body for different reasons.